You all should certainly feel free to interrupt me. If you raise your hand, I may or may not notice it. So please do feel free to speak up when you have a question or a comment. So this is joint work with Frances Liu, who is a graduate student here at UCSD, and she's excellent. She'll be on the market probably next year. So just wanted to put that out there as somebody to keep an eye out for. You know, the title is a health-based title, right, where we're thinking about persistence in child mortality risk. But I'd like to try a pitch on you from a broader perspective in thinking about intergenerational mobility in developing countries and the idea of persistent inequality. And the reason for doing that is because I think there is a long-standing tradition in development economics thinking about inequality and destitution in a multidimensional way, and so you know, it takes me back to when I was an undergraduate, first discovering my passion for development economics, when I read Amartya Sen's book, Development is Freedom. In, I think, the first chapter of the book, he has this quote where he says that the role of income and wealth has to be integrated into a broader and fuller picture of success and deprivation, right? And so the idea here is that we can think about things like mortality as being part of whatever welfare or well-being measure we're trying to chart across generations if we're thinking about persistent inequality, right? And so I think of this paper as integrating Sen's perspective with a newfound interest in the literature in estimating and thinking about economic mobility in developing countries, right? And so there's a resurgence in interest in estimating intergenerational mobility in a number of contexts, not just developing countries, but also rich countries. But in the last few years, I think the sort of Raj Shetty revolution in thinking about these ideas in rich countries has spread out to other parts of the world, and there are a number of papers coming out in top journals now thinking about this question of how strong the persistence of socioeconomic status is across generations. In particular, thinking about education, thinking about how correlated children's and parents' education are. And thinking about how those correlations or how those persistence measures vary across space, both across countries and across subnational regions within them, right? In a way that's similar to the Shetty et al. Perspective on intergenerational mobility across subnational areas in the US. Right? And so the focus in this literature has been on education, in large part, I think, because income is very hard to measure in many developing countries, right? And so, you know, persistence in education is interesting in itself, but many economists would think first of estimating persistence in income or in wealth, and that turns out to be very, very difficult to do in most developing country contexts. There are some parallel lines of work which are going to be relevant for what we do here today, thinking about persistence in other dimensions of well-being. There's a very nice paper by Sonia Balotra and Sam Rawlings on the intergenerational persistence of health, where they look at the association of a mother's height, which is sort of a noisy measure of cumulative health shocks in childhood, the relationship of her height with the mortality risk of her children. And so relative to them, we're going to look more directly at you know, the occurrence of child mortality in one generation, the occurrence of child mortality in the next generation. So there's going to be a stronger parallel with the literature on intergenerational mobility, which tends to have the parent's outcome and the child's outcome measured in the same way. Okay? And so, you know, if we take this literature and say that we want to measure persistence in some dimension of well-being across generations in another dimension, and we integrate it with Sen's view of destitution and inequality, we think this is relating to a classic body of work in development economics dating back to the early 90s. That tries to understand sources of persistent inequality in developing countries, right? When the poor stay poor across many generations, right? Rather than some stochastic process where lineages enter and exit poverty or destitution from one generation to the next. And so what we're going to do is to contribute to this literature by studying intergenerational persistence in the burden of child mortality. And one way that we're going to sort of pivot the view on child mortality is that the main takeaway numbers I'll give you are actually viewing child mortality from the perspective of the mother, right? And so so in this way, we're going to be studying the association in cumulative mortality risk to the mother between the grandmother and the mother. And this relates to a new demographic literature with some very nicely published papers in top general interest science journals over the last year or two that changes the focus of mortality from the individual to that individual's connection to survive the individual, right? So so switching from the person who died to the people who are bereaved of the person who died. One very relevant contribution to this literature thinks about the accumulation of child deaths to mothers. And it turns out, of course, that the cumulative exposure to child mortality for a mother is much higher than each child's probability of death, right? And I'll show you some maps of these prevalences in a slide or two. They reach very, very high numbers, such that in many African countries, a majority of middle-aged women have experienced at least one child death. Right? So this is really a very prevalent thing, and we think that it's quite relevant for well-being inequality. There's now quite a lot of nice evidence, both from the medical literature, that's this site here, and from the economics literature, that's Person and Ross and Slater, showing that bereavement, especially a surprise bereavement, so losing somebody who you didn't expect to die, can have physical health manifestations. Okay, so the first part of the paper is going to basically be on thinking about how we can estimate this intergenerational persistence, taking into account possible measurement errors, taking into account the accumulation of risk with fertility and the accumulation of risk with age. And then the second part of the talk is going to then build on that basic estimation exercise to answer two questions. The first question has to do with my original motivation of thinking about inequality in multiple dimensions. And the question is basically, is this form of persistence in a very important determinant of well-being just sort of a reflection of socioeconomic immobility, or is it another thing altogether, right? So in that sense, would socioeconomic immobility be a sufficient statistic for persistent inequality, or do we learn something new that goes beyond it by estimating these mortality associations? And then the second question is sort of a parallel to thinking about what happens to intergenerational persistence in income with economic growth, right? To think about the distribution of economic growth across persistently rich lineages and persistently poor lineages. We can think here about how this persistence evolves during times of aggregate progress. In this case, it would be aggregate progress against mortality. So we can think what happens to mortality persistence as mortality declines in aggregate, right? And so you can flip that question around and ask it in a different way, which is basically to think about whether the benefits of aggregate mortality decline, and this is going to be, child mortality decline driven by improvements in nutrition, improvements in sanitation, by oral rehydration therapy, and by public health measures, right? So these are going to be broad-based gains against mortality, right? To think about whether those were evenly distributed between high and low mortality lineages, or if instead, say they were biased toward higher mortality lineages, so that higher mortality lineages get a disproportionate benefit from aggregate mortality decline, right? And in that case, we would see this persistence parameter decline as aggregate mortality declines. Okay, so I promised you a picture. Here's a map from these demographers who are working on cumulative mortality exposure to mothers. This is showing, so this is per 1,000 women. So, these very dark colors, like above 500, in those countries that have these colors here, over half of women in their late 40s have experienced at least one under 5 death, right? So you can see here in sub-Saharan Africa, the cumulative burden of child mortality to women is exceptionally high, right? Such that in most sub-Saharan African countries, at least 40% of middle-aged women have lost at least one child. Right? And so our starting point is going to basically be to estimate the intergenerational association of this event to the woman. Okay. Tushar, are you thinking, or are you confused about something?
No.
Okay.
I'm all good.
Okay, sounds good. In this Zoom setting, you basically get to have a front row of a few faces, right, on the side of the screen, and those are basically the only faces I can react to. All right, so let me give you a quick preview of what we're going to do and what our results are, and then I'll jump into the data. The primary exercise is to estimate associations between grandmothers and mothers in the occurrence of own child mortality. And so we're going to do this in surveys that ask women who are respondents to list all of their own children ever born with mortality status, and to also list all of their mother's children ever born, so all of their siblings ever born with mortality status. We're going to take several different cuts of the data. There are a few different ways that you could think about modeling this, but we think of the simplest number to take away is the association in the occurrence of any child death at any point over the woman's life cycle. And what we find is substantial persistence. So a woman who had any sibling, at least one sibling, die under 5, has 39% higher odds of having any of her own children die under 5. So we measure this proportionally because it evolves over the life cycle, right? The woman accumulates risk of having a child die as she grows older. So this proportional measure of persistence stays stable over the life cycle, whereas the absolute gap between women who have a deceased sibling and women who don't grows, such that by the end of the age period that we're able to observe in the late 40s, the absolute gap in risk of having had a child die is 7 percentage points, which is quite large. You'll see it graphically in a couple of slides. So we'll then sort of probe this and add some covariates to the association. We'll show you that neither the grandmother's fertility nor the mother's own fertility matters much for this difference in cumulative risk. Education accounts for a little bit, but by far the most successful explanatory factor is locality. So it seems that something about geographic inequality and mortality risk is accounting for a lot of this, right? People, geographic location is persistent from one generation to the next, and some parts of the country within countries are much unhealthier than other parts, right? So then, items 3 and 4 are thinking about those final 2 questions I posed on the last slide. We find that this form of mortality persistence is basically unrelated across countries to measures of educational mobility, right? So that it seems that this does represent a distinct form of persistent inequality. And we also find that persistence tends to fall as mortality declines in aggregate, right? So that is to say that that aggregate mortality decline, at least over the past half century or so, has been tilted towards these families that had persistently high mortality in the past. There are some details here about how that really only shows up for the absolute measures. So for the absolute gap between women from higher mortality and lower mortality childhoods, and not in proportional persistence. And the way you can basically interpret that'll become clear as we go through the talk. But this is basically saying that aggregate mortality decline disproportionately benefits high mortality lineages in absolute terms, but not enough to have them catch up in relative terms to the low mortality lineages, right? Because they're starting at a much higher baseline level of mortality. Okay, so let me actually get into data for you. So we're going to be using data from the demographic and health surveys. These are surveys of women of childbearing age, generally 15 to 49, in many developing countries. So these have been carried out in probably about 90 countries, in many of them many times. All of these surveys have birth histories that ask women to list all of their children ever born with basic information on sex and mortality status, age at death if they died, and so on. Some of the surveys also have sibling history modules, which basically look exactly the same as the birth history module, only instead of asking about the woman's own children, the interviewer asked about all of her siblings, all of the children born to her own mother. These sibling history modules were not designed to collect data on child mortality. They were actually designed to collect data on adult mortality. They were basically intended to fill in gaps in mortality measurement for countries that had very poor vital registration systems, right? So for a lot of African countries, we knew that a lot of people were dying of AIDS, but we didn't actually measure it very well. And so by adding some questions on sibling mortality, researchers were able to gain some insights into the prevalence of HIV mortality. The same is true for maternal mortality, right? So in places that have very poor vital registration systems, we knew little to nothing about the prevalence of maternal death. And so by asking these women about their sisters' experiences, we could learn something about maternal mortality, right? So this is sort of a new thing to use these modules to learn about sibling death in childhood, and there are going to be some concerns about for example, omitted siblings if they died in early childhood. Now, I'll talk about that later in this slide, and then later on in the talk, I'll run some Monte Carlo simulations to show you what that sort of misreporting might do to our estimates. Okay, so we're going to use every survey that has a sibling history module, and that's going to reduce the coverage of the DHS from that 90+ number to 44 countries that are concentrated especially in sub-Saharan Africa, because the sub-Saharan African countries are the places where researchers were most worried about poor vital registration, and were most worried about maternal mortality and AIDS mortality, right? So these modules do tend to show up in African surveys more than in other parts of the world. But so we end up with 44 countries, 117 surveys from those 44 countries, and overall we get 1.3 million women between the ages of 20 and 49, sort of born between the 1940s and the 1990s, right? So this is notably, like, this is over an era, right, when child mortality was declining quite a lot. We're going to also be studying the outcomes of their children, right, who are going to be basically born between 1980 and the present, more or less. Okay. So I gave you a heads up that there are going to be some question marks about the sibling history module. In this module, the respondent lists all of her maternal siblings with their survival information. As I mentioned, originally these were designed to learn about adult mortality, and we're using it to learn about under 5 mortality for the siblings, right? And so there's a huge literature on using these sibling histories to learn about adult mortality. So there are concerns about measurement error, and there are also concerns about biases from sampling, because you're sampling women who have survived until the survey, right? And so there's a big literature about those issues for measuring adult deaths. There is not a big literature on using these modules for measuring child deaths, but one can imagine that the concerns, for example, about leaving siblings off of the list would be even larger for siblings who died in childhood than for siblings who died in adulthood, right? And in particular, you might be especially concerned that a sibling who died before the respondent was born never actually made it into the respondent's consciousness, right? Like maybe the grandmother never even mentioned it to or the respondent's mother, that is to say, never even mentioned it to the respondent, for example, right? And so we are going to be attentive to this issue, and we'll run some Monte Carlo simulations of one plausible version of this measurement error process, and I'll show you that it doesn't really affect our estimates very much, but I'm keen to hear if you find that compelling or not. Okay, so here's an image of the sample countries. As you can see, sub-Saharan Africa, it gets the lion's share of the sample, but we have a few Caribbean and Latin American countries, and also a scattering of countries across Asia and the Pacific. Okay. So here are some overall summary statistics for the sample. The average woman is about 32 years old, so that's relevant for thinking about her cumulative risk of exposure to child mortality and of cumulative exposure to fertility. And you can see that here in the bottom two panels, where I compare the sibling counts and sibling mortality counts with child counts or fertility for the women, and child mortality counts for the women, right? So these are siblings. So this is the mother's fertility and her exposure to own child death. And these are the woman's children. So this is her own fertility and her exposure to her own children's death, right? And so this number here, 5.67 siblings, is larger than children ever born, right? And of course, we can even add one more to this sibling, because this is not family size, right? So if you include the woman, this would be 6.67. So it's substantially larger than the 3.36 down here. That's partly driven by fertility decline, so that women are having fewer kids than their moms, but also partly driven by the fact that most of these women haven't finished childbearing yet, right? Because we're catching them anywhere between the age of 20 and 49. Right? Yep.
Can I have a quick question here?
Yeah, go ahead, Sam.
So do you have any idea about, like, for those women who have any deceased sibling compared to those women who never have any deceased sibling, is there any difference in terms of their family size, in terms of the size of their siblings?
In terms of the size of their, or in terms of how many siblings they have?
Yes.
Yeah. I think the results I'll show you a little bit later will imply that there isn't much of a family size difference, or at least that it's not large enough to play a meaningful role in this persistence.
Right. Yeah, that may be true.
Oh, actually, sorry, I can tell you that sibling mortality rates are higher in larger families, which I guess is not surprising, but that I do know that is clear in the data.
Yeah, that would be my guess too, because like if you have deceased children under 5, you want to compensate that by giving more births.
Ah, also yes.
Right.
Uh-huh.
Yeah. All right. Thank you.
So there is that, which isn't the thing I had been thinking about. So thanks for raising that. But there's also the fact that, larger families, especially in the current era, also tend to be disadvantaged families, which have higher fertility.
Yes, that could be true too. Yeah.
Yeah, but actually that was less true back when these women were children, and so maybe your story is the one that is actually more relevant. Thanks. So I was just about to say that the number of child deaths is higher here. The number of sibling under 5 deaths is higher than the number of child deaths. But if you were to divide this number by this number to get a fraction of siblings who died, and divide this number by this number to get a fraction of children who died, the rates are actually pretty similar, which is surprising, right? We know that mortality declined a lot in developing countries over the last half century or so. And it's surprising that we see similar burdens of child mortality for siblings and for children, right? And so there are 2 leading explanations for this. One is that a bunch of deceased siblings are being left off of these lists, and that's potentially a real problem for us, right? The other is the sampling-based explanation, where this divided by this as an estimate of child mortality rates is biased because we are oversampling high survival families, if that makes sense, right? We're not going to be able to disentangle those two things. I'll show you a little more evidence on sort of how well the sibling mortality rates correlate with under 5 mortality rates measured from other sources. But the bottom line is that we do need to take very seriously the concern that that siblings might be left off of these lists, right? And particularly siblings who died might be left off of these lists.
Can I have another quick clarification? So
Absolutely.
the child mortality, does that include the stillbirths, that kind of mortality, or it's just live births
Here
and
it does
died?
not.
Yeah.
Here it does not. At least the survey does not. It asks to not include stillbirth. So they ask like how many children have you had that were alive when they were born, right?
Okay.
And they ask the same for how many live births did your mother have, and then they ask about subsequent mortality experiences. So stillbirths are not included in these counts.
Okay.
Why do you ask?
Because I mean, if you want to have the full picture of these child mortality and its persistence, I would suspect that those women who are more likely to have stillbirths, then their children probably were born weaker as well. I don't know. I'm not sure if there's some sort of correlation. So in other words, the actual mortality actually is higher than what you observe, right? Yeah.
So in these surveys, they do ask about miscarriages and stillbirths, but the measurement of those two is, I think, much more difficult. And they do not include, they don't ask for full lists of it. They ask like only in the last 5 years or something like that, and they definitely don't ask for the respondent's mother either.
Right.
Yeah. But yes, I agree with you that it would be useful and interesting to include stillbirths in this. Okay, so the takeaway point from the bottom two panels here is that measurement error in the sibling mortality in both the number of siblings that were born and in sibling mortality is a concern. To sort of allay that concern a little bit, I just want to highlight that we do pick up quite a lot of sibling mortality. Okay, so 32% of our sample reports at least one sibling having died under 5, and some report quite a lot. Some even report 5 or more siblings having died under 5. Right? And so these bars are lower than would be ideal if we think that sibling mortality should be a mirror image of the prevalence of child mortality when these respondents were children, but there is meaningful variation in the data in sibling mortality. To see a little bit more about how well sibling mortality rates are measuring child mortality risk at the time that respondents were children, we can compute the share of siblings who died under 5 in the DHS, that's here on the y-axis, and compare it with the under 5 mortality rate as measured, as estimated by the UN, by UN statistics, when the respondent was a child. Okay, so each one of these points is a different country by 5-year birth cohort. Okay. And so we're basically taking the average of sibling mortality in that country by cohort cell, and then comparing it with the child mortality rate during that 5-year period in the UN data. Okay, so one thing that's nice, there is a positive relationship, right? So we see more siblings dying when the UN estimates that the country had a higher child mortality rate, but this is noticeably less than 1. So the correlation is about 2/3. Ideally these would line up along the 45-degree line, but they don't, right? And so, as I said, one possibility is selection on survival, which induces a bias of unknown sign. Actually, I could go either way. And the other possibility is that we are omitting siblings. So this is actually sort of another. I'm trying to be transparent. This is not a great graph for us, but it just signals to us that we need to take very seriously the possibility that we're mismeasuring. Okay, so let's set that aside for now. I'll come back to it with the Monte Carlo simulation in a few slides. Michael, do you have a question?
I'm thinking about it. I'm sorry, I didn't want to interrupt you, but now that you said
Go
it,
ahead.
the definition of sibling, is it biological sibling, or is there any space for a scenario where, you know, we had a disaster, we had conflict or whatnot, and the neighbor's parent or the neighbors were killed, so now we're taking their 3 kids. Like how, and I haven't thought that through, that's why I didn't want to say anything, but how, like, is it clear that it's biological siblings, or is it just who I grew up with in the same household? Would that play any role, or is that sort of nitpicking?
Yeah, so these are supposed to be biological maternal siblings. So all siblings ever born to the respondent's mother, right? And so that is, you know, the maternal distinction is important as well. So for sure, there is a lot of child fostering in many countries in the sample. And many countries in the sample also have polygyny, so that you know, there would be many half siblings, for example, who are not included in this list. This is just siblings who were born to the same mother as the respondent.
Okay, so going back to how you motivated it, effects on well-being, like how are you only interested in biological siblings, or are you interested in who I grew up with in the same household? I mean, again, it might be a nitpicking question, but it's kind of something where I might.
Yeah, that's right. I mean, once we start thinking about the social network that's associated with the death, right? You can start expanding that further and further and further, right? And indeed, actually, there's a lot of interest in the US in this demography literature. There's a lot of interest in thinking about how many extended family members people have lost, say from COVID-19, right? And so that turns out to be much higher for African Americans than for whites, for example, right? Anyway, so you can extend this further and further and further to think about the burden of bereavement. Here, you know, my hands are sort of tied by what I can see in the data, right? But that's a very interesting point. Yeah, thanks.
Thank you.
Sorry, just to add on, just to pile on. I mean, here you're following the children of the same mothers, but in the African context, it's fairly likely that those siblings will have different fathers, especially in some countries relative to others.
Sure.
So
yeah.
you're silent on the role of fathers in any of this?
I don't have. I certainly don't have data on who the fathers are for the siblings, and I don't have uniform data on fathers for the children either. Although I could possibly, with some work, try to figure it out by matching it with union histories that exist in some of the surveys. But
you've also got like,
yeah, this is a paper about mothers, and I don't know much about the fathers.
Fair enough. All right, thanks.
That's a great question. Both of these questions are very good because, yeah, and both of them get at the same idea, which is that I'm thinking about a very narrow slice of intergenerational relationships in the family, and you all are saying, but hey, what about all these other intergenerational relationships? And they're super interesting. Yeah. All right, so let me actually show you some positive stuff after I showed you the negative stuff, and I'll come back to the negative stuff in a few slides. This is just showing the basic intergenerational pattern. Okay, so I'm just comparing women who had a sibling die in childhood, that's up here in blue, with women who had no siblings die in childhood. That's over here in reddish orange, whatever that color is. And you can see here, right? And on the y-axis here, I have this is the share of women who had at least one of their own children die, right? And so you can see here that as women get older, the risk of having a child die accumulates. It grows much higher, and that's because number one, they're having more children as they get older, and number two, their children are you know, exposed to risk of death for a longer time, right? And so women accumulate child deaths as they get older, and they go from, you know, at age 20, you know, something like 10% of women in the sample have experienced a child death, and by the late 40s, over 40% of women have experienced at least one child death. But the relevant thing for us is this gap between the two lines, right? By the end of childbearing, that gap is well over 10 percentage points, although part of that is being driven by between country variation, because we have some countries that have fairly low child mortality rates and some countries that have fairly high child mortality rates, right? And you can imagine, right, that that's going to account for some of the apparent persistence in our sample. We want to focus just on within population variation because we have sort of a convenient sample of countries, so we don't think we're getting a global picture of this persistence, and so we'd like to calculate an average within country persistence across all the countries in our sample, and that's what this gap is here. So basically, this is calculating the gap between women with a deceased sibling and without a deceased sibling within each country separately, and then taking the weighted average of those gaps. That's what this gray area is, right? And so it shrinks a little bit. Right?
Tom?
But what? Sorry.
Tom, clarification. So is this the same cohort of women across age, or it's a cross section but different women at different age, so they could be different cohorts?
This is a cross section of women different ages, so they are of different cohorts. That's correct.
Okay.
But it's mixing together lots and lots of different surveys. So so it's not like all the 20 to 24-year-olds are from the same cohort. It's mixing and matching a lot for sure.
Oh, okay. So the distance is not just well, okay. So this upward sloping could be a cohort effect.
Is that these women are giving birth during an era when child mortality rates are lower than these women. Is that what you were going to say? Sorry for cutting you off.
So no, it's okay. So it's kind of mix up of both the age effect and the cohort effect.
Yes, I think
all together.
Okay, that is a very good point.
Okay, all right.
I'll add that to the paper. Okay, so you can see here that that both the share, both the level here grows with age, and also the gap grows with age, right? And that sort of suggests that we might want to think about doing a proportional model, right? Because it could be that in absolute terms this is smaller than this, but in proportional terms relative to the level of mortality, the cumulative mortality risk at those ages, that actually the proportional gap stays constant. And indeed, if we take logs, or in this graph we're taking the log odds and plot how this is exactly the same graph, just with the log odds instead of the share on the y-axis. And what you see here is that the gap in the log odds, which is sort of a measure of the proportional risk between the two groups, stays roughly constant, right? And so this is going to motivate us to start out with using a proportional model to estimate this gap when we take it to a regression, and then we'll back out some average marginal effects at the end of the reproductive life cycle. Any questions about that?
So Tom, a quick question, and this might be trivial. So should we be worried about the survival bias for the mothers in these graphs? So could it be that, you know, mothers who saw sibling death under 5 are likely to die early or likely to have high maternal mortality rates during childbirth?
So maternal mortality is an order of magnitude smaller than child mortality risk, and so I think in terms of bias, the risk from adult mortality is much smaller than the risk from child mortality. I mean, we are necessarily oversampling mothers who survived childhood, and oversampling therefore families that had higher survival rates, right? And so that is there. My guess would be that maternal mortality per se is quite small relative to that broader concern.
Yeah, but what I'm worried about, it could it be selective, right? So could it be different across these two groups to the extent that the family members share the health capital?
Yeah.
It could be higher among families who have lost a sibling early on compared to families which are healthier on an average, right? But yeah, I take your point. Maybe it's too small.
Yeah, I mean, I guess I'm basically saying that I'm basically agreeing with your concern. Yeah. But I'm saying that that selection problem probably comes earlier in the life cycle.
Yeah. Cool.
Yes, but of course we can only measure the offspring mortality for these women who survive to adulthood, right? So yeah. Okay. So with that said, having basically made the point that this proportional representation of persistence is probably the right starting point. I'm going to introduce a few models and then show you some estimates and then delve into those estimates. Okay, so we're going to estimate 2 mother level models and 1 birth level model. Okay, so the mother level models are basically going to be trying to estimate the association of sibling deaths with cumulative maternal risk of losing a child over her life cycle, and then the birth level models are just going to look at each child's risk of death. And so I'm trying to represent this in as flexible way as possible. So I wrote it as a generalized linear model. And so I basically want to think about some nonlinear response function here. That's this eta, which is either going to represent the logit of having lost any child, so that in that case it would be a logistic regression, or the log of the expected value, the expected number of child deaths, which would be a Poisson regression. So this is either going to be a logit for any death or a Poisson for the count of deaths. And then we're going to regress that on survey fixed effects. So all of these estimations are going to be within survey variation. Okay. We're going to have a flexible sort of function of age here, right, to control for this accumulation of risk as women age. So we'll have a bunch of age dummies. And then we'll have a measure of sibling death and a measure of the number of siblings that were born, right? And so the measure of sibling death is going to either be the indicator for any sibling having died or the count of siblings who died. And then, so we're going to be interested in running this both for the probability of any death and for the count of deaths, right? And when we start thinking about the count of deaths that the woman experiences, it'll be interesting to compare it with a separate model that fixes the number of kids, right? Where we do things at the birth level instead of the mother level, and that'll speak to the role of fertility in the cumulative risk to the mother, right?
Tom, before we move on, so the number of siblings, does that include only the survival, or it also include those who deceased?
This is all siblings ever born.
Ever
right?
born, okay, all right.
So we're actually going to run models with and without this covariate, right? So we think of this as picking up the role that the grandmother's fertility, the respondent's mother's fertility, plays in this, cumulative number of kids who have died, right? And then for thinking about the role of the woman's own fertility, we can compare the results from the Poisson model, where we measure the count of child deaths, with a birth level model, where basically we're asking about like how the number of sibling deaths the mother had is associated with the probability that a given child dies, right? And that removes the role of maternal fertility. Sorry.
So this is related to my earlier question that whether grandmother might actually choose to produce more babies if she experienced any child deaths. Yes. So in other words, that the number of siblings might be related to the number of siblings die under 5, right?
Yes, so I agree with that. Of course, those extra siblings might also have a higher chance of dying, right? Yeah. It's not obvious that would lead to bias. The easier response, I think, your concern is very justified. So I'm not trying to say otherwise. But in practice, we're going to find that this covariate doesn't really do much of anything, right?
Okay, that's good. I think I would prefer to have.
It doesn't change our basic estimates at all.
Yeah. But I think it's good to have it. Yeah.
Anyway, I think it's most useful for comparing with and without to understand what is the role of differences in family size between high mortality and low mortality families.
Right, sure.
And it turns out that it plays a very small role, which surprised me. I'm a guy who thinks about fertility a lot, and so I always liked to have something to say about fertility, but it appears to play little role in these results.
Tom, just a quick question about the specification. So with the survey fixed effect, the variation that you're identifying off is basically across cohorts, right? So they're mothers from different cohorts. So
There's within cohort variation as well, right?
With the survey, yeah, definitely. But the graph that you plotted on earlier, if you were to draw that with the survey fixed effect, the variation for women at different ages will come from different cohorts.
That's right.
Right.
Yes.
And
right.
so I'm just like wondering that to what extent this relationship is capturing just a time effect, just a improvement in technology, improvement in health overall, compared to the intergeneration transfer of health capital per se.
Yeah.
I'm going to be horrible and jump in on top of that if I can, Tushar.
Yeah.
Yeah, sure.
Sorry, because I mean, I see your map of Africa earlier, and the countries I'm most interested in, which are Liberia and Sierra Leone, are missing, which is unfortunate. But I mean, they arguably have the highest infant mortality, child mortality, and maternal mortality of all the countries in Africa, especially for a certain part of your sample period. And yet, and we're talking about Africa here, but I mean, to me, it seems that war, conflict plays such a major role in terms of determining fertility rates. If you look at Afghanistan, when the troop surge was going in relative to today, I know a whole bunch of other stuff happened, but in Sierra Leone, I mean, this is certainly the case. Liberia, it's certainly the case. And so I worry that even though you're looking at within survey variation, that somewhat there is some trends over time. I mean, one would be the fact that after the Cold War, there is significantly less war across the continent, perhaps. Well, now there's an uptick, but there will have been quite a lot in the 80s, and then a little bit less, and then a lot more now, perhaps. But I worry. Well, to what extent should I be worried about that?
Yeah. Actually, hold off on that thought, because I will have some results on conflict later on, at least for the child generation. For the sibling generation, it's a little harder, but I will have something to say about conflict later on.
Okay, thanks.
Tushar, the cohort effects playing an important role in these age effects, that's for sure, right? And actually, in the current write-up of the paper, we don't acknowledge that clearly enough, right? And we could actually do a little more, and maybe as an alternative to including these age. Obviously, if we include the survey fixed effect, we can't include both age and cohort effects, right?
Yep.
But we could instead. But since we're combining lots of different surveys, the age effects are not exactly the same as cohort effects, right? And we could think about running the model with cohort effect instead of age effect, and seeing whether beta 1, which is the thing we really care about, is sensitive to how we model age or cohort, right?
Or could I recommend, if you just throw in a cohort fixed effect in here, then your age coefficient will be capturing just the variation across age, right? Then the cohort effect
but there's not enough. So the survey fixed effect has a time effect. A year of survey embedded in it, right? And so then year of survey and age and cohort are collinear. So we can't.
So you can't put all three, but
include all three, right?
Yeah. Okay. Yeah, I see. Yeah, sure.
Yeah.
Actually, you could do it with a cohort fixed effect, because fixed effect will not necessarily be. So one of them is a linear. So age enters linearly.
Yeah, we could include a cohort effects that are orthogonal to a linear trend or something.
Linear
like that.
trends, yeah, exactly.
I don't think that exactly solves the problem that you have in mind.
Fair.
But thanks for these points. We haven't thought enough about cohort effects, and this is very useful. Okay, so I'm going to try to speed up a bit. So I just want to emphasize. We run the mother any result, right? Any child death on any sibling death, because it's easiest to interpret. It's like a very clear number, right? The other estimates we have are a little more difficult to interpret, but we think it's very interesting to compare the mother level count regression with the birth level regression, because if differences in family size matter a lot, the count regression might show us more persistence than the birth level regression. But if family size variation is not very relevant to this cumulative persistence, then they'll show us quite similar results. Right? And then, the any sibling death covariate is again nice because it's interpretable, but it's not going to be very useful if we're interested in thinking about how this association changes as mortality declines, because the distribution of sibling deaths is going to change a lot. And so it's going to be a lot more informative to use the number of sibling deaths as a regressor. Okay, so here are a bunch of estimates. Okay, so we have this first set of columns, the any logit for the mother, and then we have the count regressions for the mother, and then we have the birth level logistic regression. In the top, we're measuring in the top panel we're measuring any sibling death as the covariate, and in the bottom panel we're measuring the number of sibling deaths. So I'm running a little short on time, so I'm just going to highlight the things that I think are most useful to take away from this table. Try to not interpret all of the coefficients while I'm saying this, because you'll get lost and take nothing away from this result. So I want to first focus on these results up here, right? So this is the simplest thing to interpret. It's just a logit of own children, any own child death on any sibling death. And this is an odds ratio, so this is saying that any sibling under 5 death is associated with a 39% increase in the odds of any own child death, right? If we calculate the absolute gap at the end of the age period we're studying, so at age 49, that amounts to a 7 percentage point gap between women with any sibling death and without any sibling death. And you can see here, Simon, this is for you, right? That siblings ever born does not really controlling for siblings ever born does not really change the coefficient very much. I will just say, without delving deeply into interpreting the coefficients, that the exponentiated coefficients from the Poisson regressions are quite similar to the exponentiated coefficients from the logit regressions, which is to say that the similarity of these two estimates says that the grandmother's fertility doesn't really account for much of this. And the similarity of these two model results suggests that the respondent's fertility doesn't really account for much differential exposure to child mortality rates. However, I'd like to, in terms of interpreting the point estimates quantitatively, since I have just about 20 minutes left, I'd like to just focus on one last set of estimates and not go through the whole table. I'd like to focus on these down here, which I think of as being the second most interpretable estimates, right? So these are a regression of child death for an individual child on the mother's number of sibling deaths and her number of siblings ever born, right? So we're fixing the woman's, we're taking out the respondent's fertility here because we're doing this birth by birth, and we're also controlling for her mother's fertility, right? So in some sense, this is how much a child's chance of dying changes as the number of siblings who died increases, controlling for the number of siblings, right? And you can see here that this amounts to a 9% increase in the odds of death and a 1 percentage point increase in the probability of death, okay? And so I want to say one more, actually, in the interest of time, I'm going to skip over this. Yeah, I'm going to skip over these because I don't have much time. There were six different specifications, and then with siblings ever born, without siblings ever born. What we're doing here is we're simulating omission of siblings who died, right? So we're just starting with the sibling counts and the sibling death counts that we observe in our data. And then we're saying, well, okay, what if there were what if we took this to be the truth? For each sibling who died, there was a 5% chance that the woman left that sibling off of the roster altogether, or a 10% chance for sibling death, or even as high as a 25% chance of leaving the sibling off of this sibling mortality module if that sibling died, right? And what you see here, these are basically the estimates of the odds ratios or the incidence rate ratios from the Poisson regressions. And you can see here that that as the probability of omitting siblings increases, we don't get that much change in the estimated parameter, right? So this is just to say that that we don't think measurement error poses that form of measurement error where women have some chance of omitting siblings who died does much to bias our estimates of mortality persistence. Okay, from here on in, I'd like to sort of probe the results further by number one, including some covariates, and by number two, relating these estimates to measures of education and mobility, and also tracking how the persistence evolves as aggregate mortality decline happens. Somebody have a question? Oh, okay. I'd like to focus attention though on that last regression specification I showed you. So we're going to do this at the birth level. That's really useful if we want to try to track how these things change over time, right? If we do things at the mother level, it's a lot harder to think about changing mortality conditions, right? So what we're going to do is estimate a birth level regression of child death on the mother's number of siblings who died and her number of siblings ever born. And so we're going to use this throughout the rest of the talk, right? These are less interpretable than the mother level any regression, but it's a lot more flexible for studying how these associations change as mortality declines. So the first thing I want to do is I want to control for some other variables. But this is sort of ad hoc covariates as are available to us in the DHS. You can see here that so if we start out with an odds ratio from the Loja regression of about 1.09, we get some reduction by controlling for education and an asset index. We don't measure income very well here, and we can end up with a little more, somewhere around 20% reduction in the odds, or the odds ratio moves 20% closer to 1. Which is the null hypothesis here, when we control for education in the asset index. We get a lot more bite if we control for cluster fixed effects. So we can't control for cluster fixed effects. We need to focus on clusters that have some child mortality in them. So the sample changes a little bit. So we recompute the baseline estimate up here, and we find that it moves closer to 1 by about a half, right? So these cluster fixed effects are accounting for about half of the variation in child mortality persistence. So one question then is whether this is because of sorting of women to different localities to different survey clusters, different localities or city blocks in adulthood, or if it's because of their inherited place where they were born. Unfortunately, we can't do a ton to address this question, but one thing we can do, because we don't actually have data on where women were living when they were kids, but some of the surveys ask women, have you been living in this place all your life, right? And so we can restrict attention to those women who say that they were living in the same place all their life, right? These non-migrants. And you can see here that here again, if we include cluster fixed effects, so this is just for women who have been living in the same place all their life, those cluster fixed effects account for about half of the variation. Right? So something about place, right? And place is capturing a lot of stuff, right? It's capturing some socioeconomic variation. Maybe that's not being picked up by our individual level socioeconomic measures. And it's also obviously picking up aspects of the public health environment and infrastructure and things like that. Right? Okay, and then, the only thing we can say about the role of health transmission in all this is to control for height. And that's actually what the Ballotra and Rawlings paper had done, the restat paper from Ballotra and Rawlings. And that appears to, maternal height is correlated with child mortality risk, but that accounts for very little of the mortality persistence. Okay, so what I'd like to do next, sorry I'm moving a little quickly here, but what I'd like to do next is to think about this question about how much of this is just reflecting socioeconomic persistence across generations. So we already have one answer to that, one version of an answer to that, which is that education and assets don't appear to explain a ton of the intergenerational relationship. They explain some, but not a ton. And so maybe, socioeconomic status doesn't play a huge role in this. That I don't find that answer to be totally satisfying. Another way we can ask the question is to say, okay, well, what if we estimate these parameters for each survey separately, right? Just to estimate basically the association of maternal sibling death with maternal own child death, and then to also compute in that same survey the association between maternal schooling and child schooling, right? So the association between maternal schooling and child schooling is picking up something about socioeconomic immobility, and basically we can then ask, are places that have higher educational immobility also the places that have higher mortality persistence, right? I'm not going to go through the details of estimation here because I want to get through the whole talk. But the bottom line answer is that there isn't a very strong association, that countries or places that have higher education persistence are not generally the same places that have high child mortality persistence. So for sure, when we measure these things proportionally using odds ratios, there's no relationship. When we measure them in absolute terms, so this is basically the percentage point gap in child school enrollment rates between children who have more and less educated moms, and here the percentage point gap in child mortality rates between women who have deceased siblings, women who don't. In absolute terms, there is a positive slope here, but the R squared is 0.14, right? It's not a very strong relationship. So I take this to mean that these appear to be two largely separate forms of persistence, right? In important determinants of well-being and living standards. Okay, so this difference here between odds ratios and average marginal effects between proportional persistence and absolute persistence is interesting. And it's going to be especially interesting for thinking about this last question that I want to tackle, which is how mortality persistence evolves with aggregate mortality decline, right? To think about, like, does aggregate mortality decline disproportionately benefit high mortality lineages or low mortality lineages, or is it broad-based and even across those two groups? Right? And so the distinction between proportional and absolute gaps is super relevant there. And so what I'd like to do before I get into this this exercise is to just think about the relationship between the odds ratio and the marginal effect, right? So this is basically saying if the baseline mortality risk, this is just for a binary risk factor. So think here about women with any siblings who died and women with no siblings who died, right? And to think about that odds ratio, right? And so if the baseline risk of child mortality for the women without deceased siblings is 5%, right? There is an increasing relationship between the odds ratio we would compute and the marginal effect, but it is a lot less steep than if the baseline risk is higher, right? And that makes sense, because if the baseline risk is higher, then the same proportional difference is going to get magnified into a much larger absolute gap, right? And so then you can think, if we start out with a baseline risk of 20%, right, what are the possible trajectories for these two different measures of mortality persistence, right? And basically, mortality persistence, as mortality declines, as these rays rotate downward toward the horizontal axis, child mortality, the two measures of child mortality persistence can either move in this direction or in this direction or in this direction, right? So that actually leaves open a lot of possibilities, right? And so it's possible for both of them to decline. Whoops, sorry about that. It's possible for both of them to decline. For both of them to decline would be like this, right? Where both the proportional measure of persistence and the absolute measure of persistence would decline, right? And that in some ways like a strong version of progressive mortality decline, right? So this mortality decline is so preferencing previously high mortality lineages that it is both closing their absolute gap relative to low mortality lineages and also having them catch up in relative terms, right? In proportional terms, right? Then you could also have the marginal effect declining with the odds ratio increasing, right? So that the proportional difference and the absolute difference are moving in opposite directions. And finally, you could have both of them increase. In that case, the low mortality lineages are getting the bulk of benefits from mortality decline, and the high mortality lineages either aren't, right? So that it's magnifying persistent mortality inequality. And so just a heads up, what we're going to find, we're basically going to find something like this, right? That the odds ratio doesn't change very much, but the absolute persistence, the percentage point gap between women with more and fewer deceased siblings is going to shrink. So let me tell you about how we're going to do that. We're going to construct a country by period panel of persistence estimates and relate them to child mortality rates in a two-way fixed effect model. So, we're going to focus on mortality conditions at the child's birth. So the conditions in the mother's birth period, you might also be interested in sort of how things were when the mother was a child. So those aren't always available because many of these women were children during a time when mortality data were sparse. And we also think that it's complicated it would be complicated to interpret those results because we think that, if the under 5 mortality rate when the mother was a girl might be correlated with a recall error. And so we're going to try to avoid that and just focus on child mortality rates when the woman was an adult and giving birth. And so what we're going to do is we're going to estimate this birth level logit of, the logit of death on the number of siblings who died and the number of siblings ever born. And we're going to estimate this separately for each country by 5-year period. And then we're going to take these beta estimates and turn them into either odds ratios or average marginal effects and treat those as outcome variables, right? So for each country by 5-year period, we're going to have an estimate of the odds ratio or an estimate of the average marginal effect, and we're going to regress it on the child mortality rate, country fixed effects, and period fixed effects. So this is basically going to tell us, as mortality declines within a country over time, what happens to mortality persistence. And so here's what we get. So all of these coefficients are positive, which is to say that as child mortality declines, these persistence estimates also decline on average, right? So I mean, this is child mortality rates are positively associated with persistence, but in practice, most countries are experiencing declining rates, and so you should think of it as persistence declining along with child mortality. It's only statistically significant, however, with the absolute measure of mortality persistence, right? And so what we see here is that high mortality lineages are benefiting disproportionately from mortality decline, but not so much that it is, at least in any statistically significant sense, closing their relative gap relative to low mortality lineages. Okay, so if we want to think about how large this panel association is in quantitative terms, on average in the sample, child mortality rates decline by about 15 percentage points. Okay, over the periods under consideration, so about 150 deaths per 1,000 live births. And if we multiply this 0.15 by these coefficients over here, that basically suggests that the absolute persistence term declines by about 0.01, right? Which is quite large relative to it's about the same as the mean estimated parameter, right? So this is quite large relative to the amount of persistence we see in the data. Okay, so I am nearing the end of my time. So let me just quickly summarize the results and offer some thoughts about like broadening back out to thinking about Amartya Sen and persistent inequality. I hope to have convinced you that the risk of losing a child persists intergenerationally in data from 44 developing countries. I would say that if I did one of these, social science prediction platform type exercises where I ask researchers what they expect my results to be before I actually do the analysis, that most of you would probably have said, yeah, I think that they'll probably be associated. Like it seems likely that, women whose moms had children die will also be more likely to have children die themselves, right? So in that sense, like maybe, the basic result is not that surprising, but I do think the magnitude is new and would have been difficult to predict, I think. So, you know, this 39% higher odds for women who experience any sibling death is quite large, right? To me, it was surprising that fertility, both the grandmother's fertility and the mother's fertility, seems to matter little to the results. Also, I think it surprises me that mortality persistence is not just a direct reflection of socioeconomic persistence, right? I would have expected a much stronger association between the degree of education and mobility and the degree of mortality persistence. Right? The panel results on what happens to these associations as mortality declines gives us a new way to think about the distribution of benefits from mortality decline, right? And so, you know, usually we think of the benefits of mortality decline as being distributed along socioeconomic lines, right? Like, so, like how much mortality decline did low education households experience, and how much mortality decline did high education households experience? And this is a different way to think about it. Instead, we're thinking about we're categorizing the population according to how much historical mortality the lineage was exposed to. One final thing I want to say is that you know, the importance of the location fixed effects is quite interesting for thinking about sort of how governments can try to reduce persistent inequality, right? And in particular, you know, thinking back to Sen wrote a lot about growth-led mortality reduction and support-led mortality reduction, right? Where support is basically, you know, public health programs and nutrition programs and, you know, broad-based government programs that can improve public health even without economic growth, right? And a lot of people have called that the Kerala model. Sen wrote a lot about the Indian state of Kerala, which had sort of middling to poor economic performance, but exceptional performance on health and education measures, right? And there are a few other countries along these lines too. China and Costa Rica and Cuba were some other examples he wrote about, and I guess Sri Lanka was the last one that he wrote about. And so, you know, this sort of brings the question, right? If we're having trouble breaking socioeconomic immobility, right, breaking sort of the persistence of poverty across generations within the lineage, can we make some attempt to reducing persistent inequality in a broader sense by rolling out large-scale public health programs, which can sort of sever, which may be able to sever some of these mortality associations, right? In the sense that place is capturing some you know, health infrastructure or something else about the environment that is leading to persistent mortality risk. That seems quite interesting, and I think that dovetails well with our finding that you know, that aggregate mortality decline seems to have shrunken these gaps. Anyway, thanks very much. These were really useful comments. I really appreciate it.
Thank you so much, Tom, and right on time, so well timed. What I'll do now is I'll end the meeting formally, but if you have some time to stick around and, like, you know, answer a few questions, that'll be really nice. Yeah.
Absolutely.
So all right, let's do that. So let's all thank Tom for an amazing talk. And you know, if somebody has to leave, they're free to go. But if you're interested to talk to Tom, please stay behind and, you know, continue this conversation. So any questions? So if not, then I'll start with mine, actually.
I have a quick question.
Yeah, sure.
So first of all, a very interesting paper and very interesting results. What I wanted to understand, and what I'm still probably a bit not clear about, is, are you so what's the measure? You know, is mortality another alternative to socioeconomic mobility, or is it something orthogonal to that, in the sense that, you know, when you said that geography matters a lot, so that encapsulates a lot of things. It obviously encapsulates, you know, the in general socioeconomic development of that area, but it probably also captures environment. It also captures heat or whatever. It probably captures genetic, you know, variation as well. So when we are talking about welfare, how should we view your results as? Is it probably a subset of socioeconomic mobility, or is it something that kind of begs the question that you need to look at some other aspects of socioeconomic development as well?
Yeah. Thank you for that question. So my take on the results is that they point toward this being something else that might be partly related to socioeconomic immobility, but is not just socioeconomic immobility, right? And you brought up genetics, right? I didn't say much about genetics. I don't know much about genetics. But that could be important as well, right? So part of this, for example, I gave this talk at IFPRI, and Harold Alderman said, "Hey Tom, what about genetics? Like, you have, just for example, you could think about the sickle cell gene, right? And you could think about that as accounting for some share of the variance in mortality risk, right? And so how should we think about that here, right? Well, I guess one reaction would be that, that is a real persistent variation in an important outcome, right? And we shouldn't necessarily discount the variation that has genetic sources, right? Anyway, so that's a very good question. I don't have a perfect answer for it, but I do think that the results suggest that this goes beyond just say persistence in income across generations, something along those lines.
Indeed. Yep.
Thanks.
So just to follow up, Tushar, do you want to go first?
No, go ahead.
Okay, so Tom, just to follow up on Nagir's comment, and so one of your major conclusion is that it seems surprising that this persistent mortality is not really, doesn't have that much to do with the socioeconomic status persistence, but that also kind of supporting the it's the nature versus nurture. So the nature side probably had a role in this, but I would like to think the other way around, is that because mortality is a very extreme outcome, right? So maybe it's not really about the mortality. If you want to think about the persistent in socioeconomic status, maybe it'll be more captured in less extreme outcomes, such as the health outcomes that's not that extreme. But of course, like this paper doesn't deal with other health outcomes or other indicators. But I want to know what's your take on, if it's not that extreme outcome, could it be other less extreme outcome?
Yeah. So thanks for that question. I can think about it conceptually. Practically, I'm not able to measure the other I'm not able to measure less extreme outcomes. Certainly not for the older generation, right? For the siblings, I'm only the only thing I'm able to measure is whether they existed and whether they lived or died in childhood. There is work on industrialized countries on intergenerational associations in birth weight, for example, right? And you can even get some causal estimates out of it by comparing siblings or even twins who were born at different birth weights, and to look at the birth weights of their children, right? And those estimates suggest that a lot of the intergenerational transmission of birth weight, or a lot of the intergenerational association of birth weight, reflects environmental determinants of birth weight. Basically, in the case of twins, it's basically who had the better position in the womb that determines which kid had a larger birth weight. And so in those samples, the within twin pair estimates of birth weight effects looks very similar to the overall sample estimates of the association of birth weight across generation. And so that suggests that in utero health matters a lot for these persistence measures, right? I have no idea whether it would be similar for mortality, or if it would be similar even for birth weight in developing countries. I would suspect that, environmental determinants of health, right, like shocks that happen in utero, for example, would be a larger share of the variance in poor countries than in rich countries. So.
And that's related to this growing literature and talking about the epigenetics, the environment causing the mutations in genetics, and that can pass on across generations. Yeah. Right. Thank you.
So can I follow that up with a slightly related question, which is, so I'm more of the belief that it's basically not the genetics, but the exposure that you have to infrastructure and knowledge. So I was wondering if you could do something, I'm thinking of the recent Amy Finkelstein paper about, the destination specific factors and how they affect mortality. Can you do something like that in this setting? Because you have information, you don't have information on where they migrated from, but you have information on when they migrated, and you have information on retrospective birth history, right? So can you look at the intergeneration persistence before they move to the destination and after?
I actually, you're right. I do have information on when they moved.
When they moved, yeah.
Oh, that's
so if you can show that this transmission actually weakens once they move to a better destination, or strengthens once they move to a better destination, then
but I don't know if they moved to a better destination, right? I just know that they moved, right? I guess I know that they moved, and I know whether they're in a better, possibly whether they're in a better or worse place now.
Yeah.
Whether cross-sectionally their place now is better than their sample mates or not, right?
But one thing you could do is basically look at the intergenerational persistence between the mother and the woman before and after the movement, right? So even if you don't know the destination is better or not, you could see to what extent that persistence breaks down once they move, right? And that would indicate that it's not so much about human capital transmitted, but it's about the persistence exists because of places and not because of people, right? So families, and that'll be really interesting in my opinion. But the other question I have was about education, right? So the measure of education persistence you're using is whether or not they went to school, or whether or not which to me seems like I know you might not be able to do much better than that, but to me seems like is a really crude measure, right? I mean, there's education is one, but there's also knowledge and information and the quality of learning that you have, right? And to me, like when it comes to health, that's what matters more. Compared to just, and there's a big literature, about it, like in Africa and in South Asian countries, degrees are, you get degrees, but they're not as, quality wise, they're not as good, right? So something to think about. And the third thing, that last thing, and then I'll shut up, is basically, could you is it possible to break down that place effect? Like, so suppose you took the, fixed effect, the cluster fixed effect that you had, the estimates, and you ran it on a bunch of infrastructural variables that you have for the cluster, and perhaps kind of indicate which measures or which infrastructure variables matter most.
Yeah, that's very interesting. That seems doable. I think the data available for like the clusters might vary from survey to survey, but the surveys do certainly have some information on how things look in the cluster, and that would be a very interesting thing to do. So let me be totally honest. Currently, we've written up the paper as a short paper, and so we are like right at the word limit of most of these journals that are experimenting with short formats. And so these are all really, really excellent ideas. And so I think they would, if we fail at the short paper and eventually turn it into a long paper and send it to some other journals, I think it would be really, really interesting to explore these things. And so I'll write them down and I'll keep them for when I fail at the initial couple of.
Hopefully you won't. Hopefully you won't fail.
Thanks. That's really great.
Yeah, that's all I had. If there are any other questions, please speak up, or we'll let Tom go. It's really late.
I have a quick one, if there's time. It's a bit left field, but somehow, like the location thing, what Tushar mentioned last, is what I found really intriguing as well. But now that you mentioned you are at word limit and you may not want to do that, but it reminded me of this paper. Guys, maybe you remember Toma and Barspai, who presented last year a paper called Local Convergence of Behavior Across Species, which is in Science now, where he shows that these sort of historical aspects of geographies like species in a particular location behave the exact or very, very similarly across like species now over, I don't know how long of a time period. But basically the point is that there's something in a location that we can't just explain with these time varying factors that explains how we behave. And in one way, this is also an aspect of behavior. So I'll send you the paper anyway. And again, it might be not related to what the line you're thinking about at all, but you could certainly measure, in addition to what Duchamp mentioned in terms of infrastructure, but weather historically, disasters historically and such. And if you have particular clusters, a handful or so within each country, you may certainly be able to delineate them. Like perhaps this area is really prone to having droughts or whatever, and sort of break down that cluster fixed effect a bit more. I mean, that's one question that I came up with in your presentation. I was really interested in what is it that is specific to that location that explains it. But yeah, like as you mentioned, you are sort of, you're at the limit of words there, so maybe you don't want to go that route. But that's an interesting question. I thought
Yeah,
that might.
I would love to see that paper if you can send it to me.
Yeah, I'll send it to you. It's a really cool.
I think one question that you might get elsewhere is basically this period coincided with the HIV epidemic as well. Yeah. And that created a lot of uncertainty around, like your economic well-being and whatnot, and uncertainty. And, I think to some extent, Maya's paper is also related to that. Then uncertainty can cause long-term effects on, child health and, whether or not you can hold a pregnancy. So that question you might get as well, the HIV one.
Yeah, we did some work, including HIV mortality in those panel regressions, right, where we've computed the parameter for each 5-year country cell, and it didn't change anything very much. I mean, it absorbed a lot of the. I mean, it's very correlated with under 5 mortality, right? So we wound up with some collinearity issues, but we didn't think we learned anything very interesting from the exercise, so it didn't really make it into the paper. But, yeah.
All right. So if there are no more questions, we'll let Tom go. It's really late in San Diego.
Yeah, that's right.
Early morning lecture to teach, apparently. So.
Yeah. A 3-hour one, nonetheless.
Oh, okay. Well, good luck with that after this.
Okay, thanks very much. It was so nice to chat with you all, and hopefully sometime we can see each other in person. That would be really nice.
Well,
yeah, indeed.
I've always looked at Perth on the map and thought I would love to one day get to that corner of the world that's so far away from where I am now.
Let the borders open up and we'll send you an invitation.
Yeah, sure. Sounds good.
All right, Tom, thank you so much. Have a good night.
Take care, everyone.
Okay, bye.
Bye.